I think it should start recording now also. So let me go back to the screen. Okay, so welcome once again to the first lecture. So it's theory of analytic functions. So maybe this lecture and the next lecture, I don't know, maybe we will not really start the course. We will be just testing the thing, and any difficulty that you observe either now or in between, either you tell me by unmuting and or you message on WhatsApp. I am logged into our group. Okay. So so today we will not really do anything other than just testing some features and very basic things. I will remind you. Uh, we will just recall differentiation. But before that, let's have some introductory statements. So I have typed everything. Usually I will not write many things on the blackboard in a usual class, but I talk a lot. So here also that may be the case, but since there's no blackboard, etc., certain things I will type on my slides. Anyway, the basic. This is a second course on complex analysis, as you know. It's an elective, and all of you have registered for this. So many of you have already gone through a basic course in complex analysis. Either you might have had the BTech course 205. I think in this class everyone would have had 412, not 205. So MA521 must have run in the last semester, and maybe because of lockdown, etc. I don't know how much you have covered, but anyway. So you had some complex analysis course before. This is after that, but we will try not to assume much other than the very minimum, and everything we will cover once again and cover as much as possible. I think it should be doable. So as you know, it's a very beautiful subject, and I'm sure all of you will enjoy the course. Do pay attention from day one because of various reasons, even in usual day-to-day real class where we meet face-to-face, also one should pay attention from day one. But even more important now, uh, okay, so Saurav Kumar has sent a message that he is finding it difficult to join. All of you can see the other team members, or only I can see? One of you can tell me, Chirag or Aryaman?
Yes, sir. I can see.
And can you see Saurav Kumar is part of the team? I thought I have added him. Saurav Kumar.
Sir, I can't see who the other team members are. I don't know how. Okay, I can.
That's what I was asking. So
Yeah. 1 second.
you can?
Yeah.
Saurav Kumar.
1 second. No, he's not here.
I can see who the participants here are, but I don't think I can see the team members.
Not on the participants already here.
Yeah,
but
he's not
okay,
here.
so 1 second. Let me just see how to add. I thought I added him yesterday. So give me 1 or 2 minutes. Can someone from MSc confirm, Saurav Kumar? So all your numbers will be 1900 starting, no? Someone from MSc
Sir,
will
third
know
number.
this. Or you can also see the screen. So third one. Okay, I was going to touch the first one. It's the third one. Your
Yes,
classmate
sir.
Saurav Kumar is third, no? Ending 27, right?
Yes, sir.
Okay, good.
That number he had given the group as well.
You could join, no? Okay, good. Okay. You can hear me? Saurav? You can unmute. Saurav, you can unmute. You can hear me, no? Okay, I assume he can hear me. If there's any difficulty, as I said, message on WhatsApp. So let's go back to the slides. So we are just starting, Saurav. We haven't said much. So do pay attention from day one and discuss amongst yourself and also with me, where we can use Moodle and WhatsApp and email, whatever. Okay. Because it's online and I'm using Beamer, etc., I don't know the pace. So maybe, sometimes we may go faster. So you slow me down in that case. You tell me that, the last class was too fast or too slow or whatever you feel. Let me know immediately so that I can correct in the next lecture itself. Also in my slides, if you notice typos or mistakes, do point out either in the class itself. Feel free to unmute and talk. I have no problem in your interrupting me. In fact, I encourage it. Okay. So do point out either in the class itself. Sometimes what will happen is even if you point out in the class, I might forget. So send it on WhatsApp or email. WhatsApp is better. Then I will correct it soon after the class, and the corrected slides I can post. Yeah. So even if it's a minor typo, spelling mistake, please do correct, because as much as possible, we should have the slides as correct as we would like it to be. This one I already mentioned to you that IIT Bombay mandates that all the lectures to be recorded. So I think I have already started recording. Let me just double check. Yeah, I have already started recording, and so all the lectures will be recorded. All the lectures will be recorded. If you prefer, what we can do is maybe even in terms of the size of the file, maybe it's better if you divide it into several parts. So lectures, let us divide to 2 parts. Anyway, continuous online lecturing for 1.5 hours is a bit too much maybe. Also, I would like you to engage, so you to talk. So we can divide every lecture into 2 parts. So what can happen, for example, is the first lecture part can continue for 30 to 40 to 45 minutes, and then I will stop recording. So one of you can remind me if I forget. I will stop recording, and then we can have 10 or 15 minutes where we will just talk. Okay, it can be about what we have covered or what we are going to cover, what is coming next, so that you will also get extra focus. I will also get extra focus. So we will just talk, and that can be recorded separately, this 10-15 minutes. So most important is for us to talk. Now, if you don't have anything to say about what we are doing, right, then that's also okay, but you should talk. You can say something else. You can talk about coronavirus if you want. But we will all talk to each other for 10-15 minutes or maybe 20 minutes. And then we will come back, because it's a 1.5 hour lecture. So 10-15 minutes we will talk, and then we will come back, and the second part will be recorded separately, and this in between part also we will record. So there will be 3 recordings, but the difference is this: the first and the third part, where it's the slides and proper actual mathematics, part of the syllabus that we are covering, this will be made public. the department has a YouTube channel and they are asking us to send our recorded videos. So this will be made public. Whereas the second part, which is the middle part, right, where we are, I mean, I'm hoping all of you will participate and we will actually engage with each other and where we are talking, clearing our doubts. So, you know, you can ask very basic questions. I mean, don't feel shy because even though it's recorded, it will not be shared in public. Only the team members, only this class will be able to see that video, if at all. So don't feel shy. We all make mistakes. I myself make a lot of mistakes. So don't feel bad about making mistakes. It's okay. So you can ask any question. It can be, you know, you might think it's a trivial question, but nothing is trivial. You know, someone else also might benefit from your question. So that's okay. So second part will be available only for the team members. You don't need to feel shy that it will be made public. It will not be. Public part will be the first part and the third part where I am lecturing. There also you can ask questions, but that will be part of the public video. Is what I am planning. Let's see what's happening because, for example, if the video size is too large, maybe it's difficult to upload to YouTube, etc. I don't know. We will see. So please do attend all the lectures. You know, sometimes you might feel anyway it's being recorded, so the video is there later. So why should I attend all the lectures, etc. But I encourage all of you to attend all the lectures because, you know, going through a video later, it's quite boring. It's better to be, you know, in a live session. And also there will be some discipline. We are all meeting twice a week at the right time. So please do attend the lectures. And of course, all of you will be worried about exams and grading, etc. because we are not in IIT. So very frankly, I also don't know because it's the first time we are also, I'm also doing this. So it will evolve. So let's see. Let's also see what others are doing. What are the best practices followed by others in IIT, including in other departments, and we will see. So let it evolve. So the general advice seems to be to have continuous assessment. So we will have some such thing. You can also suggest from, you know, your other courses if you have any inputs how assessment should be. You feel free to tell me. So we will evolve some policies and come to some specific guidelines in next 2 or 3 weeks. Anyway, after that only, I mean, it's a 4 month thing, so there's no hurry. So we will decide on it a bit later as the course starts. Okay. So let me just, when I'm on this screen, I can't see you. So let me just go back there. Yeah, all of you are there. And by the way, I mean, feel free to be on video if you want. And even you can unmute and once in a while you can say something if you want. Once in a while I'll come here and see all of you are here and I'm not, you know, talking in plain air. So what about the books for the course? It's good to have one book and to follow it consistently so that you have that also to refer to. There are several excellent books for the subject. Our syllabus on our department webpage mentions 5 books. These are books by Lars Alfors, John B. Conway, Theodore Gamlin, Raghavan Narasimhan, and Walter Rudin. So we will mostly follow Rudin. In fact, I have Rudin with me right now, and we will mostly follow Rudin. So which book is this? Rudin has several books, and 3 of them are very famous analysis textbooks. What is usually called Baby Rudin by many of us is the book that you might have followed for your Real Analysis 1 course. This is a second Rudin. It is titled Real and Complex Analysis. The first part is measure theory and the second part is complex analysis. It's a second part of this book that we are interested in. It's a fairly advanced book. It's a slightly difficult book. It's okay. We will go through it. There's also a third book titled Functional Analysis, which you may or may not see in the future. That's also a great book according to me. Okay, so this is the Rudin's second book, The Real and Complex Analysis, as our textbook. Please get a copy and go through the parts that we are going to cover in a lecture before coming to the class. I think this is important. I think this is very useful if you have the book and if you actually skim through the pages that we are going to cover the next day, then before coming to the class, if you have gone through that, then you will get a lot of extra focus. You know what to focus, and you know which parts you haven't followed fully. So it's in advance where your doubts are going to be, so you can pinpoint your doubts and ask those. So here is one thing which we could probably discuss when we take a break. Here are 5 famous mathematicians, and their textbooks are there in our syllabus. So let's get to know. I mean, this is just for pure fun, in order to make you talk. Let's get to know the above 5 mathematicians: Alphonse, Conway, Gamlin, Narasimhan, and Rudin a little bit more. So what you can do is when we take a break for 10-15 minutes, you can on your mobile or on your laptop, whatever you have, you can check their Wikipedia pages and talk a little bit. Okay, so let's see. So we will do this. Let's come to a little bit of maths. I don't want a lecture to be completely devoid of any maths. So I will follow exactly as in Rudin. We are blindly going to follow Rudin. All the notations will be from Rudin. Sometimes, I might take some problems or some other thing from online or whatever. Wherever I deviate from Rudin a little bit, I will tell you what my source is. If I don't say anything else, it is all copied from Rudin. Okay, so my slides will be basically copy paste from Rudin's real and complex analysis. Okay, so this will not be mentioned again and again. It's all from Rudin. Notations are from Rudin. Proofs are from Rudin. Everything is from Rudin. When I add extra things, I will mention the source at that time. So omega denotes a region. What is a region? Region means a non-empty open connected subset of C. We are working with the complex plane, and a subset which is non-empty, it's connected, it is open. Okay, this is where we will do our analysis. So take a function defined on this region. It's a complex valued function. All our functions, of course, it's complex analysis, complex valued. And take a point Z0 in omega. Now the question is, what do you mean by, of course, you know all these things very well. We are just recalling, test drive, so to say. So let Z0 be in omega. The function f is differentiable at this point. Then you know the definition, a certain limit exists. So that's what the next line is. It has a derivative at Z0, which is denoted by f prime at Z0 if this limit exists. So what is this limit? Limit z going to Z0 of this quotient. Numerator fz minus fz0 and denominator z minus z0. Right? All of you have seen all this many times. If this limit exists, then we say that it is differentiable at that point, or it has a derivative at that point. Okay. So the point is, this limit existing, the existence of this limit. So you have, it's the same definition, right? In real analysis also, we usually call x instead of z, but other than that, it's the same definition. A real valued function is differentiable at a point x0 if limit x going to x0, fx minus fx0 by x minus x0, if that limit exists. So on the face of it, there's absolutely no difference, but differentiable functions in complex analysis behave very differently, in the sense behave much better than differentiable functions in real analysis. So you might wonder what the difference is. One of the difference is that this limit z going to z0, there are plenty of directions in which. So limit exists means what? Limit from all possible directions, right? Limits in all kinds of ways. All those exist and they are all equal. So in real analysis, it would be left-hand limit and right-hand limit. There are only two directions, whereas you are on a complex plane. So you can come in infinitely many lines or various other curves. I mean, limiting directions can be in various ways. So this limit exists means a lot. This carries a lot of information in it. All these different limits exist and all of them are equal. Okay. So this kind of a limit also you have seen in multivariable calculus. After all, complex numbers, as a vector space, it is just R2, right? A two-dimensional real plane. And you have seen multivariable calculus. You have seen the notion of total derivative, partial derivative and total derivative. In total derivative also, the limit there also, when limit exists, that means limit exists. All these various limits exist. But this is well behaved compared to that also. The reason being, you cannot divide a vector by another vector. So total derivative, if you recall the definition, it is defined in some other way. It's not, a quotient like this, but it's something else. It's limit of a certain norm equal to 0, which of course comes from this, but it has to be formulated exactly like that, and it cannot be formulated like this. Whereas in complex numbers, just like in real numbers, you can take the difference of complex numbers, you can take the difference of these two complex numbers, and that's a complex number, this is a complex number, you can divide. So these two features put together, the very definition of differentiable at a point, it contains a lot of meat, it contains a lot of substance, and a lot has gone into it, and therefore we will reap rich dividends. Okay, so one of the reasons why the subject has very beautiful results is our definition itself is it has a lot of substance in it. Okay. You would have seen this definition earlier. F is said to be holomorphic on omega. So this is what you have to notice. I never say holomorphic at a point. I say differentiable at a point, but I don't use the word holomorphic at a point. I always say holomorphic on an open set, on a region, on an open domain. Okay, so holomorphic on omega if it is differentiable throughout, if the derivative exists at every z0 in omega. The class of all holomorphic functions in omega we will denote by h for holomorphic, h of omega. This is what is the main player in this course. This is what we will study. So the whole course is about studying this set h omega. So note that this is a point I mentioned already. Holomorphicity is a stronger condition than differentiability. You can check, for example, if you take this function mod z square, you can check that it is differentiable at 0. Please do check maybe after the class. And it is differentiable only at 0. Because it is differentiable only at 0, in a small neighborhood of 0, it's not differentiable everywhere because it's differentiable only at 0. Therefore, in particular, it's not holomorphic. It's not holomorphic anywhere. It's holomorphic nowhere. Because in order to be holomorphic, it has to be differentiable in a small open small region. That's not happening, right? Only at one point it's differentiable. So there is this slight difference between differentiability and holomorphicity. Holomorphicity, I never talk of holomorphicity at a point. I talk about holomorphicity only in an open connected set and on an open set. And so differentiability does not mean holomorphicity. This is the only difference. It is about differentiability, but differentiability throughout. I hope that point is clear. This also I mentioned, you would have seen the notion of a total derivative in real analysis. So you could view this function f from omega to c as a real function of two variables, right? It is f of x comma y is u of x comma y comma v of x comma y. You could view it like that, and then you can observe. So this is a small check which you can do. If f is complex differentiable for us generally means complex differentiable. I may not always stress. So if f is complex differentiable, you can check, you can think of it as a real function of two variables, and you can check what is its total derivative. Does it exist? And if it exists, what is it? You can check that the total derivative is nothing. So total derivative, if you recall, is a linear transformation, right? So in this case, it will be from R2 to R2, and that is nothing but multiplication by the complex derivative. So please do check this. It's a very easy computation. You just need to know the definition of total derivative and our definition of complex differentiable. Put those two together. You will see, you can write down the matrix of that linear transformation, the Jacobian matrix, and you will see that that is nothing but the action of f prime z0 on C thought of as R2. Okay, so do check this. So you should see this. We can also discuss in our break, or maybe you can check it later. Maybe you need pen and paper. What is a converse statement? you can ask for a converse, is a converse true? So formulate the converse of this. So this statement says that if a function is complex differentiable, then it is real differentiable as a function of two variables, and total derivative is nothing but the complex derivative. So you can ask, what is the converse statement? And you can also ask, is the converse true? So let's discuss that also in the break. Okay. So I think it's time for the break, and we started around maybe 5 minutes late, 9:35, 9:40, 10:06. So yeah, it's good time to take a break. So let me stop recording and start a new recording. So let me stop recording. So if anyone wants to be part of the recorded video with your video on, please turn it on. I'm going to stop this. Anyone wants to be on the video, turn it on. This is the time. You will come on the video. Okay, shall I stop this? Fine. Yeah.